Understanding the equipment. Brake systems. Safety first. When working in the shop, always follow the safety guidelines provided in service information, tool operation manuals, and other technical literature. To protect yourself from injury, wear personal protective equipment, PPE, dress appropriately, work professionally, and correctly handle tools and equipment. The modern brake system uses mechanical, hydraulic, and electronic components to slow and stop the vehicle. This video will introduce you to the components and operation of the brake system. Braking begins when the driver presses on the brake pedal. The pedal is a lever which increases the force applied by the driver against the brake pushrod. The movement of the pedal, which is monitored by the brake pedal position sensor, activates the brake lights. Pedal movement is also used for the anti-lock brake system, the electronic stability control system, transmission control, and other systems. The movement of the pushrod forces the pistons in the master cylinder forward. This pressurizes the fluid in the cylinder. The fluid passes through the anti-lock brake hydraulic control unit, which supplies the brake fluid to the calipers and wheel cylinders located at the wheel brake assemblies. All modern cars and trucks have disc brakes at the front wheels. The disc brakes consist of a caliper, a brake rotor, and brake pads. The most common type of disc brake is the floating caliper design. When the brakes are applied, brake fluid exerts pressure against the back of the caliper piston. This causes the piston to move out of its bore. This force is applied against the inner brake pad. Because the caliper floats on its mounting hardware, the outward movement of the piston forces the caliper body backward, which squeezes the outer pad against the brake rotor. The clamping action of the pads against the rotor creates a lot of friction and heat. The friction slows the rotation of the rotor, wheel, and tire, and the heat is dissipated into the air. Another type of disc brake design uses a fixed or stationary caliper. In this arrangement, the caliper is bolted in place, and pistons located on either side of the rotor apply pressure against the pads. This type of brake is often found in high-performance applications. Drum brakes are an expanding brake design. When the brakes are applied, fluid pushes the two pistons in the wheel cylinder outward. This forces the brake shoes outward against the inside of the brake drum. Springs pull the shoes back when the driver releases the brake. The parking brake is a mechanical or electromechanical system that locks the rear brakes once the vehicle is parked. Until recently, most vehicles had a completely mechanical system, using steel cables to connect the parking brake handle or pedal to the rear brakes. Many newer models use electronic parking brakes. These systems use electric motors to pull the cables or to activate a parking brake mechanism in the rear disc brake calipers. The anti-lock brake system, or ABS, is used to keep the wheels from staying locked, which allows the driver to maintain steering control while braking. Modern vehicles incorporate the ABS with traction and stability control systems to help with overall vehicle handling and control over many different types of operating conditions. Now, enter the simulation for more on brake system components and operation.